Today, we will deploy containerized application to AWS Elastic Container Service, or ECS in short. We will go through it step by step, which will include building the Docker image. We will push that image to AWS ECR, which is Elastic Container Registry. You can keep your images there. And then we will create ECS cluster, ECS service, and task that will run that container. I decided I'm going to use only AWS command line interface for that, and in AWS console I will only show you what is being built after we run each AWS CLI command. I just want to show you that you can work with AWS Cloud in many ways. You can obviously click buttons directly in AWS console to build that. We also saw in previous videos how to use Terraform, which is infrastructure as code tool, and today I thought maybe we will just use AWS CLI to perform all those tasks, because why not? And you will find all commands used today in comments section below, so you can easily reproduce that in your AWS cloud if you want. You can deploy any container you wish this way, but the container I decided to use is the same container we already used before. It's the RMBG container. It's an image with Python application that lets you remove the background of the images. Maybe instead of explaining, let me show you what this end product will look like when we have finished the entire process. I will simply go from any computer in the world. Once I have it deployed, I can simply go to the browser. Let's open the browser. And I can go to the URL of my choice. So I chose Automation Avenue. This is the domain I own. So I just added that REMBG in the front, and the application works on port 5100. So this is this application. It's running on port 5100, and what it can do, it can remove backgrounds from any image I want. I can either drag and drop or browse for that image. I don't have any images here though, so let me download one quickly. Let's say elephant. What about this one? Let's save it in downloads. So now I can go to my application, I will browse for that file, I will pick that elephant, and I just have to click select. After a few seconds, as you can see, the new file was generated, but this new file has the background removed. That's all it is. And we will build that application and deploy to ECS today, step by step. So let me destroy everything. And by the way, don't try to access this application on this URL, because I will destroy it once I have finished working on this video. But as you can see, it's a simple tool you can run from anywhere. No Photoshops, no time wasted. You just click on the file and the new one with no background is generated. I've destroyed everything now, and let's start creating it from the scratch. First I want to create a VPC. If we go to Service VPC, you will see one VPC already there, but it's the one that AWS creates for you by default. And as I said, I could click just here, create VPC, it would create a new VPC for me, but I want to use AWS CLI only. And the only requirement is you have to have AWS CLI configured. And we talked about how to configure AWS CLI, so I will not repeat it here. I will keep pasting the commands, and you will see what's happening in the background. This is the first command I need. I want to create a VPC with CIDR block of 10.000/16. Press enter. And that's it. VPC has been created. So if I refresh now in the background, you can see a new VPC with the prefix I requested. But it doesn't have any name here, so we can change that. But before we do that, let me run one more thing. I want to save this VPC identifier as a variable. And I will call that variable VPC_ID. And then I will copy it together with the quotation marks. Which means now, if I echo that, this terminal will simply remember what my VPC ID is. Let me clear that maybe. So now I can run a command like that. I will create a tag for my VPC with the value Marex VPC, and I will use that variable instead of the actual VPC ID. I hope that makes sense. Let's press enter. And now if I refresh again, this VPC now has a name of Marex VPC. Now I have to create two subnets. I have to create two because we will have to build load balancer, and the load balancer requires at least two subnets. So that's what we will do next. This is my first command. I use that VPC ID variable again. I will build the first subnet in zone EU West 2A with the CIDR block of 10.0.1.0. So let's press enter. And that's it. That's my first subnet. And what I'm gonna do, I will create another variable and I will save this subnet ID as that variable. I will call that variable subnet1 ID. Maybe let's first go to subnets and see if it was created or not. So if I refresh, you can see new subnet. You can see 3 other subnets. These are also the default subnets that AWS creates for you together with the default VPC. We are not interested in that one. We are interested only in subnet that belongs to Marek's VPC, which is this one. And we have to create another one. So let's clear. Now this is the command to create another subnet in different availability zone. It's 2B as you can see, and with different prefix. It's 10.0.2.0. So let's press enter again. Let's clear. The subnet should be created. And we can see there it is. It's a new subnet. And I will save the subnet ID as a variable as well. I can copy it from here. I can use this like 2 rectangles to copy the subnet ID. I can go there. I mean, you don't have to create those variables, it's not necessary, but the more commands we run, the more you will see why I do that. It's much easier to reference the subnet2 ID rather than this long, blah blah blah. But okay, we've got VPC, we've got 2 subnets, now we have to create internet gateway. So whatever we build in those subnets, it will be able to access the internet. And this is the command, AWS EC2 create internet gateway. Let's press enter. And the new gateway was created. We can see it here, internet gateways. And we can see it was created, but it's in detached state. But that's fine. For the time being, I will just save it as a variable. I will call it AGW_ID, internet gateway ID. And now we have to attach this internet gateway to our VPC. And this is the command. And you can start seeing why I use those variables. We've got one here, we've got one there, and I don't have to remember all those long digits, those identifiers. I can just reference my variable. So let's press enter, and if we refresh it now it is attached to our VPC. And by the way, when you create a VPC, new VPC, a new route table is also created. Let me show you that. So that was created when we created VPC, but what I want to do, I want to save this ID identifier as another variable. It's called RTB_ID. And if we go back to that route table and we check routes, we can see there is only one route. There is a local route to the prefix of the VPC, 10.0.0/16. But we will need another route to push all the traffic that does not go there. Then we will want to push that traffic to our internet gateway. And then the internet gateway will have to sort out where to push it even further towards the internet. So let me clear that. And this is the command I need. Create route. Route table ID is the variable I just saved, RTB_ID. Destination CIDR block is 000/0. That means everything else, all other traffic. And we say that it should go to our internet gateway, which we have saved as IGW_ID. So let's press enter. Return true means it was added. So if we go back, if we refresh and click our routing table, routes, we can now see 2 routes. One is the local to all resources within the VPC, and the other route is like all other traffic should go to internet gateway. And this is our internet gateway, AA6. And that's all really we need here. The last thing I have to create using AWS EC2 command is the security group. If we go to security groups, currently you can see there are some default ones that I'm not interested in. I have to create my own security group to allow only the traffic to my application. And remember that application was listening on port 5100. So again, let's open terminal. That's the command. It will create security group called ECS_SG. description security group for ECS tasks, and VPC ID is actually a reference to my variable again. So let's press enter. And that's it. Security group was created. Let me just quickly save it as another variable. Let's call it SG_ID. So if I go back and refresh, I've got new security group, but it doesn't have any inbound rules. You can see no security groups found. So let's add a rule to that security group. And this command will add a rule to my security group, and it will say that I'm allowing the port 5100 from anywhere in the world. It's that last 000/0. That means from anywhere. So let's press enter. And that rule was added. Means if we go back and I refresh again, that is our inbound rule. It allows protocol TCP on port 5100 from anywhere, and it's inbound. What we will do next, we will build our load balancer. So if we go to service EC2, load balancers, you can see there are no load balancers. So let's build one. This is the command, pretty long one. I will call it REMBG, remove background, ALB. ALB means application load balancer, and it will be deployed to two subnets, subnet 1 ID and subnet 2 ID, and I use my variables, but as I said, you don't have to use them. You can use actual subnet identifiers. And then we will add security group that I saved as variable SG_ID. Scheme is internet facing, and type its application load balancer. So let's just click enter. Okay, I must have messed up something with the subnets. Let me check the history. Oh, look at that. I saved subnet 1 ID and subnet 2 ID. I actually used the same subnet. This is wrong. Subnet 2 is wrong. A for A. Let me duplicate this. Let's go to VPC service. Subnets. And you can see A for A is first subnet, .1. Second subnet ends with E7A. So let me copy that. Let me save it correctly this time. That's fine. That should do the trick. Now I will use up arrow. I will run this command again to create load balancer. And now it was created. If we go to this tab to load balancers, if I refresh the page, we can see it's still provisioning state, but it's already there. And the load balancer will have that very long identifier. This is load balancer ARN. Let me save that as well as a variable. We will need that. So let me just clear. And I will put ALB_ID equals to that long ARN. Let's enter. And now we've got load balancer. But what we also need is something called target group. And our ECS service will be a target group for this load balancer. So we have to create target group first. That's the command, create target group. We will call it REMBG, remove background target group. Protocol will be HTTP on port 5100, and then we will use VPC identifier, I mean the variable for our VPC. And target type will be IP. Let's press enter. And that's created. And as you can see, target group also has that very long identifier. So let's save it as well as a variable. I will call it TGID. If we now refresh this page, we can see our target group was created, and there is one more thing we have to configure here for our load balancer, and it's called listener. Listener is like imagine it as a little thing, service running there that listens on specific port on that load balancer. So if we go back here, if I paste it there, like you can see previously, you can see non-associated. It's not associated to any load balancer, that target group. But now if I run this command, let's press enter. the listener was created, and now you can see this target group shows REMBG ALB as associated load balancer. So you can imagine this as being the thing that glues these both together. Awesome. And clear now. So we've got the load balancer itself, we've got target group, and we've got listener created. That's all we need for our load balancer. Now we have to build a Docker image for our application, and this is something we did before already when we run that application statically, but anyways, I will repeat that process. We go to that website, and it's not my project, it's code DIO, but this is actually the guy who has a Fireship YouTube channel, so it's a Jeff Delaney and it's his project. And he was kind enough to publish it, and anyone can download this code. So let's go to code, and I will just download it as a zip file. As you can see, it's now downloaded, so let me just go to downloads. You can still see the elephant and the new file, but basically this is what I'm interested in, the REMBG web app. So I will just unzip it. Let's enter. So this is the unzipped folder. I will cd into that folder, and we can see more files. One of those files is a Docker file. This is the application Python. This is basic Python file. And Docker file is the file that we need to build our Docker image. But let's have a look first on that. Let's clear. You can see that little instruction. Download this to avoid unnecessary download. So we will do that as a last step before we build anything. I can use command wget, then paste that link. And as you can see, it's downloading the file for me. Let's clear again. Now you can see that new file called u2net.onnx that was added to all other files. So we are ready to build our Docker image. Let me clear again. The command I need is sudo docker build -t stands for tag. Simply what I want it to be called, that image. And I will call it rembg-app. And the last, but not least, is a dot. Dot means I want to use all the resources and the Docker file that is exactly here in my location. And I'm still in that folder, remember, rembg web app tutorial. It's very important that you are here in this location to build this Docker image. So now I just press enter. I have to type in the sudo password. And the Docker image is being built. As you can see, successfully tagged, built first, and then it was tagged as rembg app. Let's clear that. And now I can run sudo docker images. You can see the rembg app has been created. Okay, so we've got Docker image, but we have to push it somewhere. We have to push it to Amazon ECR. It's like a place where you can keep all your Docker images. If we go to ECR now, you can see there is nothing here because it says create a repository. Well, that's what we have to do. We create repository first. I will call it rembg-app. That repository was created. So if I go here now and refresh, you can see I have now new repository called rembg-app. Now I will create another variable which will be my account number. This is the account number, the 888, the finishing with 4 8s. I will copy it. I will add it as another variable. I will call it ACCID. And this is my Amazon account identifier. Now I want to tag my Docker image in a specific way. I will tag the image that we've just built, rembg-app. I will follow this, it's a specific URL. You've got your account ID, then the DKR, ECR, blah blah blah. I will use that to tag our image. I will click enter, and looks like nothing happened. But if I run this command, sudo docker images, you can see a new one. This is not image, this is like a tag for that image. You can see the image ID is the same like that one, but we can then push this tagged image to our ECR. So let me clear again. I will run a very long command AWS ECR get logging password sudo docker login, and basically you can find that command here. It's a view push commands. That's basically it, alright? I just copied that, but I replaced my account, which is anyways, you can just copy it because it will be filled in with your account number, but I used variable instead of this number. So let me run it. And the important message is here, login succeeded. That means we are now ready to push our image to ECR. That's the command, sudo docker push. This might take a while. This image is around, well, I can't remember, but depending on your internet speed, it might take a while. Okay, so it took 7 minutes, but it's done now. Everything is pushed, and that's what you should see, like a long hash, and it says latest digest. So if we go there now, to our registry, to repository, sorry, if we go there, I can see my image. And you can see it's called REMBG app, and the tag is latest, and the size is 924 meg. Perfect. So let's go back to our terminal. I will clear again. I know it looks like a lot, but once you have all those commands, you can just copy paste them and have it up and running in no time, believe me. Now it takes long because I talk about every single item, but anyways, there are some few more bits that we have to configure. First one is the IAM role. This is basically a set of permissions for our ECS service to be able to pull the image, run in the cloud. It needs to have specific permissions. So that's what we will do next. I will cd one level up. So I'm back in my downloads. And I will create a new file here. And it will be our trust policy in JSON format. So I will call it ecs-trust.policy.json. And this policy will look like that. And don't worry, it will be also included in the comments below. So you will have it all in the comments section. I can save it, :wq, enter. So this is my policy. And I will create an IAM role based on that policy. So I will paste this command. The role will be called ECS task execution role, and I will use this file, this ECS trust policy JSON file, as the template. I will press enter. Oh, already exists. So looks like I didn't remove everything properly. This IAM role I forgot to remove. You will also have to run this command to attach role policy to that role name to a service role called Amazon ECS task execution role policy. I know it's a bit complicated. I don't want to dig into that too much. I will just press enter. All those commands will be included in the comments, remember. But that's all regarding the identity management, I mean. Now we can go to ECS service. So we've got the container here. If we go to ECS service, Elastic Container Service, we can see currently there are no clusters, it says. Let's create an ECS cluster. I can run this command, ECS create cluster, and then the cluster name, REMBG cluster, I will call it. Let's press enter. That's it, cluster was created. So if I refresh, it says I've got cluster, but I have no tasks running. And basically how it works, you create a cluster, which is like a main area where you will run your services and tasks. And then you can build services there, and then in each service you can have multiple tasks. For us, what it will look like, I will have just one cluster. Within that one cluster I will have just one service, and within that one service I will have one task running. So for the time being, we've got the cluster. But I want to create one more thing, which is optional, but it's regarding logging. You can enable logging for your containers, and I will do that because if anything goes wrong, it's so much easier to have that logging than to not have it. So let me clear that. This is the command I need. I will have to create something called log group, and I will name it ECS REMBG-app. That will be my log group, so simply a point where all those logs can go to. I will press enter. It looks like nothing was done, but basically if I duplicate this tab, the service where you will find it is called CloudWatch. If we go to that CloudWatch, you can see logs and here log groups. and this is the log group that we've just created, rembg-app. Okay, we're getting there. What we have to create now is something called task definition. You can see in our container service ECS, it says no tasks running. Task is where you define what container you want to run, how much CPU and memory you want to use for that container, and some other bits like logging, for example. We will add logging to our task as well, and you specify what resources will be allocated to those tasks. So what I will do now, I'm still in my downloads, I will create something called task definition. It will also be in JSON format, and you will also find it in the comments. So you will be able to simply copy-paste it. I will call it rembg task definition.json. It will be new file, and I will paste it. Maybe let me make it bigger for a while. There are a few things. This is the name for this task, rembg app container. Network mode is AWS VPC, and that's actually because we will use Fargate. Fargate means the servers that we don't have to care about. Fargate is like a bunch of servers that AWS will run for us, and we can simply deploy containers to them, not worrying much about the servers themselves. Because, container has to run on something. You can either run it on EC2, and you will have to take care of those servers, of those EC2 virtual machines, or you can use Fargate, and you don't have to worry about anything. Now, I will specify what image I want to use for our container. I mean, that's basically it, yes? Docker image is like static file, and the container is a running instance of that Docker image. I will allocate 2 GB of memory, and CPU, it might not make much sense when you look at that. What? 1000 CPUs? No, this is just one CPU. 1024 means one virtual CPU. It's done this way because you can have portion of one CPU. You don't even need to run one. For some tasks, maybe you will put even 512. That will mean half of the CPU. Or in other words, half of the time the one virtual CPU has, half of this time will be allocated for this task. And then container port, this is the port the application listens on, it's 5100, and the host port, it doesn't have to be the same, but I will just keep it the same. And this is the log configuration. And important thing here is that you use that log group that we've just created in previous step. If you scroll down, you will see I actually added those. These are also variables. This file will not work as it is now. We will have to substitute this with my actual account identifier, AWS account. We will do it next. But I wanted to point out that CPU and memory, again, it's important that these values are the same or higher than the values we have here for the container definition. If you were running more containers, these values would have to be at least some of all memories and CPUs that you would include here above. So if I had 2 of them, I would have to put like 2048 and 4096. You know what, never mind, I unnecessarily overcomplicate things. Let's just save it, :wq. This is simply my file, the task definition, but if we run cat, we still have that variables. What I will do now then, I will put this export account ID. This is my AWS account identifier. I will press enter. So that variable was exported. And now I can run environment substitution command. I will take this file that I've just created, rembg task definition.json. This command will replace all those variables that are called ACCID with this value. And once that's done, it will save this file as a new JSON file called rembg task definition-new.json. Let me just press enter and I will show you what I mean. This file has just been created now. It's definition-new.json. And if I cut this file, new JSON, you can see I have correct URLs here, there, and there. Some of you may ask, Mark, why are you even doing that? It's simply because if you want to use those scripts for example, multiple accounts, if you want to automate that tasks, it's more difficult at the beginning, but it will make sense much more later on when you work with multiple accounts and you can just change one variable. So while that might not make much sense at the beginning, it does make sense when you have to create multiple accounts, multiple tasks in multiple AWS accounts. Alright, but anyways, this is the new file. This is the version of the file that I can use to register my task definition. This is the command ECS register task definition, and I will use this new file as a template for that task definition. Let's press enter. That's it. This task definition has been created now. We are nearly there. Let me clear that. The last command we have to run is a pretty long one, so I divided it using backslashes. We have to create service. The cluster, we will use our cluster, RMBG cluster. Task definition, we will use that REMBG app-task. That was under family actually. It wasn't name, it was called family. So we will use that family. We will use our load balancer. We will run one desired count 1, and the launch type will be Fargate. And in network configuration, we say that we run it in both subnets. It's possible to run it in both subnets. And we will also attach security group that we created for port 5100 previously. So it's a pretty long one, but let's just press enter. And that's done. What it means now, we can go to our ECS, we will go to our cluster, we can see the service running. It's called REMBG service, but for the time being, it's 0 out of 1 tasks running. And we have to wait for a while, because the deployment is in progress, as we can see. So if we go to tasks, you can see it's pending. Our task is just being created. So ECS pulls the image first, it will find the server, it will run that task. We can say, oh, I forgot to remove that, two virtual CPUs, but we can actually use just one. But anyways, we just have to wait until the status changes from pending to running. We can see desired status is running. So let me refresh that. Oh, it's already running. What that means, at this stage, I can already access this application. If I go to our load balancers, load balancer, I will click our load balancer. Load balancer has DNS name. If I copy that DNS name and paste it here, let's start with HTTP. We don't have certificates, so we use HTTP only. I will paste here the URL of the load balancer, and I will add the port, which is 5100. We can see our application is up and running, and I can access it from anywhere in the world using this URL, because this is public DNS. I can resolve it from anywhere in the world, and I can access this load balancer from anywhere in the world. But what I want to do as the last thing, I want to change this name, because this REMBG, ALB, blah blah blah, who would remember that? Nobody, yes? So I've got some domains, both, but I've got them in different AWS account. And this is that different account, and I bought a domain called automationavenue.com. That means I can create a new record here. I can create a record called a CNAME, which says routes traffic to another domain name and some other AWS resources. I can call it, for example, REMBG. So that will be the address, rembg.automation-avenue.com, and I can point it to our load balancer. So if I copy this DNS again, and I will paste it to that different account, because it doesn't have to be the same account, it doesn't really matter. I will point it to load balancer, so I've got the CNAME pointing to our load balancer. I create record. Now, even from that different, browser, different account, I should be able to access it by pointing to that domain name. That's the address. If I press enter, I can also access this application. But now I've got something easier to remember. rembg.automationavenue.com. Okay, so that's it. I will destroy it again though, so don't try to access it. But I hope you will be able to build one yourself. So thank you for watching.